Thank you, everyone, for coming. And I know that I am the last obstacle between you and coffee and cocktails. So I'm going to try and keep it brief and hopefully informative. So today's topic is real-time analytics using Apache Pinot. As you can tell, Apache Foundation, so it's an OSS project, and how LinkedIn, Uber, Stripe, and many more use data at scale. So let's go back. I'm sorry. There you go. Here's the agenda, really quick. I'm going to talk a little bit about myself, a little bit about the evolution of analytics, and then we'll jump into how LinkedIn actually. So this is more of a use case scenario. Hopefully I'll get time to show some code to you as well, a demo. So let's see. So my name is Barkha Herman, 30 plus years. I know, that's a photoshopped image. So look younger, but I do run a women in technology, South Florida Women in Technology organization for women in this area. So if you're from this area, look me up. And also speaker and DevRel right now for StarTree. Let's get started with the actual, all right, so let's get to the point. Analytics, real time, scale. Why? Why do we need this? So with the fact that I've been doing this for 30 years comes the history of analytics, right? So anybody here, and I'm dating myself, remember crystal reports? Anybody? There's a couple people in the room. So yeah, back in the day, analytics was just reports, and they were ugly. And it was generally batch. And then the other thing that was kind of quote-unquote wrong or challenging about reports was that it was against real-time data, like production data. So there would be times when you run a report and production went down. So that happened, right? So it was sharing data. And also, it was really not scalable. There were like 5 managers that looked at the reports, and they were excited if you could get a monthly report. They were even more excited if they got a daily report. They were like, what? I can see all of yesterday's data in a report? That's fantastic. Compare that to, compare that with, so this is a story. I used to work for Microsoft, and I was in Seattle. It was a very rainy and cold day. I'm in a hotel. It's fancy. It's nice. But I don't feel like going out to eat, even though Seattle has great restaurants. But so I order Uber Eats, right? How do you select which place are you ordering from? Cut it out. How do you select that? First of all, you want to make sure that it's a cuisine you want to eat. Second of all, you are going to look at delivery times, right? What does that mean? That means data freshness. Because think about it, delivery time means kitchen capacity, how many orders are coming in, how many drivers are there, how is the road conditions, and all this good stuff. So that's data freshness. And based on that, we calculate something like, oh, it's a 35-minute delay versus 40-minute delay. I'm ordering from a 35-minute person because I'm hangry, right? And then if the 35-minute delay is delayed by 3 minutes, what happens? I'm not giving them a 20% tip on that. I'm sorry. The tip goes down as the time goes up, right? So data freshness is huge. And by the way, Uber Eats is one of our customers. Implemented Apache Pinot. The next one is query performance. Now think about all the people on your, let's say if I say, hey, this is my LinkedIn link, and all of you connect with me, right? How many queries does that? How many people are connecting with me, and how quickly does that show up? Query performance matters at scale. And then, of course, we're talking scale. So let's talk about LinkedIn. So this was where we started. This is, who knows what this is? This is a LinkedIn who viewed my profile screen. Has anybody used it? Yeah, we use it all the time, right? So if you think about it, you're like, okay, so backend, just as a, setting up the stage, backend, it's a Kafka implementation where every time somebody loads your profile page, you're getting an event, a message. And then it goes into a file somewhere, and then we do something with it. And now you can look at how many people viewed my profile in the last day, last week, whatever. So you're going to say, it's just a count. Come on. You just add a counter, +1. It's no big deal. But now we want to also look at what sources did you come from, right? Was it a search? Was it a direct link, whatever? Like, okay, now it's more than one count. It's still like 5 buckets, maybe. There's not that many sources. But then you start looking at relevance, right? So if you look at who viewed my profile, it's always 3 CEOs, 3 people with the title CEOs in their title, and 5 interns. And it's hierarchical. The interns don't show up before CEOs. So there's relevance to the person who views profile as well. And not to mention, if some of you are already linked with me on LinkedIn, your names show up, right? Cassandra saw your profile. David saw your profile. But for the others, it's a obscurity based on who they are, what their profile is. So it's a complex problem. So this is what was happening before Pinot, is that they were using Elasticsearch, by the way, because all the messages were on a data store, big data lake, and 1,000 nodes of Elasticsearch running, right? 1,000 nodes. They were serving 1,500 queries per second, and yes, they were using semantic search, they were using vector-based k-near neighbor algorithms. And this is to serve 20 million users at the time. So they knew that they were growing and they needed to solve for it. So it was a very iterative process, by the way. And this is the after. So after they created this product, Apache Pinot, they were running 75 nodes. They were serving 5,000 queries per second. And by this time, they had 70 million plus users. Okay, so let's talk about how. All right, so what they did, the first thing I want to say is that this was not something that they did in one pass. They thought they were improving Elasticsearch. Then they started adding more and more iterations to their product, and the end result was Pinot. They productized it, they applied to Apache Foundation, and then they released it. So the first thing that I want to talk about is that they have a distributed data store, which is the same in Elastic, it's the same in Flink, it's the same in many, many other products. The tables are conceptual, and we have partition, we have a segment, then we have table. So the table is not a real table. So in like a traditional Oracle-ish, SQL-ish place, a Sybase, whatever, it's a physical file. Or if you're sharding it, there's multiple files. But in a distributed store like this, tables are made up of many, many, many segments, right? It could be hundreds. It could be thousands. Then you have this concept of tenant, which is just a functional isolation, and then the cluster. And cluster is where the meat is. We talked about those 75 nodes. That's a cluster. So again, we talked about Kafka. That little symbol on the right is Kafka. Messages coming in, the way it works is that there's a controller service that gets the messages, and using a Zookeeper, which is a Apache product for configuration management, it will decide where it gets written, and then it's distributed. Then we have something called a broker, which actually does all the scatter-gather tasks. So scatter is taking a query and scattering it to all the individual pieces, servers, and then the gatherer is gathering up the result and doing something with it, right? And you have the option to replicate data across segments and things like that. You can kind of see the different color boxes across. So how we talked about Elasticsearch, right? What was the thing that made it faster? We quickly realized, so I'm going to tell you this, it's an OLAP database, basically. It's a distributed OLAP database that performs at OLTP levels. We quickly realized that having just a index type is not necessary. So what we did was we developed a lot of index types. It's a columnar store, so you can have a different index per column, and you can have multiple indexes. So we have inverted indexes, right? We have range indexes. If you're familiar with, I'm very sorry. If you're familiar with streaming data, Kafka, right? Most of the time, what kind of data is that? Anybody? Time series data? Have you heard of it? Right? Time series data. So what's going on? Hey, if I'm looking at who viewed my profile, I'm not looking at for the last 10 years. I'm looking at this week. So I want a series of data. Somebody looked today, somebody looked tomorrow, and so on and so forth, and it's all time-stamped. So in a range index, instead of having index per document per block, you can say, hey, all the blocks for this hour are here. So you're reducing write times, you're reducing read times, and you're reducing access times. Geospatial index, so the lady from Elasticsearch did a great presentation. The thing about it is geospatial, so this was created in concert with Uber Eats, because the way they do searches is not just, hey, where's the nearest Starbucks? They want to know geospatial coordinates. So they use this thing called H3, which is a hexagonal-based grid system where you can place which grid is closest to you and find the closest things and what grid has what thing. So that was something that we invented just for Uber. JSON index, of course, a lot of the messages that we get from Kafka, other streaming platforms, is in JSON format, and you want to be able to search across JSON, especially nested structures. And of course, we do have we do have text index, by the way. So we use Lucene for that. It has semantic search, and it has vector-based search, and all that stuff. Lucene is Apache, so it's open source. Supports regex queries and much, much more. And then finally, we invented this thing called StarTree index. So let's talk about that. So I want to ask you, what is the fastest way to find something? Any ideas? How do you find something? Bloom filter is a good way to find where something isn't, right? You know that. So if you have a cluster of 100, you can use Bloom filter at the broker level to say, hey, where's this data not? And that's a great way to find, so that's a great answer. But generally, if you want to find data, you have a ton of document, you want to find something, you use index. What kind of index works the fastest? Well, if you cube the data, it's the fastest, right? We all know about cubing. Instead of saying, hey, I have 1 million transactions for the day, and I want a sales report, if you cube the sales report based on widgets, how many widgets did I sell? Now you have a straight query. Like you can go to one record and say, for this day, give me the cube data for this. And boom, you've got everything. It's one row, one hop, you got it. But what's the challenge with cubing? You have to cube for every query that you can imagine, and that's the challenge, right? And also, some of the data doesn't need to be cubed. So we came up with this concept of StarTree index. So let's think about, let's say, a website, and you want to know web traffic. And so let's say that I have a website, it has a lot of traffic, I want to run reports on it, I want to run some analytics on it, and I know that about 80% of my traffic is coming from either US or Canada. Sorry, Europeans. It's an American website. So, so what do? StarTree index, what it does is it'll only cube US and Canada. It won't cube all the other stuff. And that's level 1, so that's the first, the D1, V1. And then the next thing I want to see on my website is what kind of browser is being used, let's say. And you know that about 80% of it is either Chrome or, I don't know, Edge or whatever, right? So, so cube that, not the rest of it. What it's doing behind the scene is intelligent cubing. And it's learning as queries come in, and it only cubes that data that is being used. So the more you use it, the more load, it actually improves because of the fact that it can anticipate what the cubing looks like, or what the cubing needs to be. So it's a hybrid cube model, and that's why the name of the company that I work for is StarTree. So this is the final thing. I can tell you, we have a lot of customers where they come in and they go, oh yeah, we implemented it and the performance is good, but we need to improve it. We drop a StarTree index for them, and boom, the performance just kind of miraculously. This is open source, by the way. Anyone can implement it. So let's talk a little bit about the architecture. So one of the challenges we talked about in one of the slides, I talked about the shape of the data and batch versus streaming. So one of the challenges that we have, there's a lot of really good solutions for only time series data that only supports stream ingestion. The thing about Pinot is that it does batch and streaming. And in order to optimize, so you don't want to do, I used to work for First Data that does about 60% of all credit card processing in the world. And if we wanted to, say for Christmas, roll out a new type of gift card, we had to run ingestion of that gift card data every night for 100,000 chunks, because we couldn't interrupt the OLAP speed. Because if we did it at peak time, that would kill the performance of the credit card transaction processing. We couldn't do that. So that's one of the challenges of having an OLTP system with batch ingestion. So in this case, what we did was we have two flavors of servers. One is a batch ingestion, and one is the streaming ingestion. So all your Kafka messages are being consumed by a bank of streaming ingestion servers. They write to the same segments. But there's no bottleneck on CPU. The writes don't cost that much. And then the batch is completely different, so you're not fighting for CPU. It's not impacting your queries and your dashboards. Your output is real time, right? Okay, so that's the story. There's a lot more to it. I won't go into a lot more detail. And so let's talk about who uses Apache Pinot. So as I mentioned, it started at LinkedIn. LinkedIn engineers invented Kafka. Then they started using Kafka, and they said, well, we need an OLAP database. So they invented Pinot. They made both of those open source. And so it is open source. StarTree is the biggest contributor for it, and it's used by a lot more people. So these are some of the people who are using it. I can tell you a couple flavors, right? So wherever there is a need for big data being reflected fast, huge data. So for instance, Stripe has petabytes of data, and they need the dashboards at scale. So it's not that only people who sign up can use the dashboard. There are literally millions of dashboards that they need to serve, and that's the scale that Pinot can provide. And then the other, some of them are easy, like Uber Eats I mentioned, and there are other food delivery systems, especially delivery system where the data, it's a very chatty interface, right? They're getting a lot of messages from everybody. There's order data, there's travel data, there's delivery data, there's order change, cancellations, traffic, weather, all that stuff. So wherever there's a lot of chatty data is a good use case for it. Okay. I'm going to, real quick, go to, so this is, oh my goodness, what happened? Oh, I guess I can't. I can't show you. It's kind of weird. Very, very sorry. All right. Sorry, guys. Let me see if I can. There you go. We could do this. No, I got it. Okay. So I wanted to share with you dev.startree.ai. We do have a Docker image that has all the services as well as some sample data installed, and you can download and run it. I don't know if I'll be able to do the demo for you here because it will take a few minutes to run it, but I want to invite you to just be here, try this out. And then the other thing is I want to show you what the actual Pinot console looks like once it's run. So you can see that you can see here that it has one control. So this is a Docker image running on my local machine. So it's got one controller, one broker, one server, one minion. So minion is the task runner for Pinot, one tenant, and 7 tables. And you can kind of, so they're all running locally, and so you can see that all the URLs are here, local. And let's go to the query console. What can you do? You can look at these tables and just run some really quick queries, and you can see that everything is happening super fast. It takes less than a few milliseconds. Of course, this is not big data because this is my laptop, so it's not running a lot. We do have demos and cloud versions available. So when we deploy to cloud, we use Kubernetes, and we have help charts, so you can deploy your own. But we have samples that use public data that you can play with, which is much faster. Like I said, it's very fast and very efficient. And that's pretty much all I have. Let me go back and so please connect with me. This will take you to that StarTree, dev.startree.ai. From there, you can connect with me personally. We have a very, very, very active Slack channel for the Apache Pinot. This is not a StarTree thing. This is Apache. It's a community Slack channel. We encourage you to download, run it locally, contribute if you're interested, and tell us, how you plan on using it. I also have GitHub repos for some, hands-on labs that we can do. I host a lot of meetups. regarding this. So if there's something you want to do, reach out to me. I'm very active on LinkedIn and the Slack here. So reach out. And do you have any questions? I'll take questions since we have a few minutes. Yeah, so the first level on the right side of the screen is the clustered, and where it says D1 star is the rest. So that's the 20%. So if you think about it, your query is 80-20. You want to optimize for 80, not the 20, right? And then you have two levels, and we're only showing two levels here. You can have as many levels as you want. It is a dimension, and so you can query by country, the region as the clustered or star, and within even the star, you can query on browser, flavor, or star. So you have the same. If you're doing queries, reporting or dashboards only on IE, then you'll go down. Only on IE, you'll go down from D1 V1 to D2 V1. If you're doing IE in Poland, you would go to D1 star, D2 V1. Does that make sense?
You mentioned cubes.
Yeah.
That's kind of an OLAP lingo.
Yeah, so this is an OLAP data store, yeah.
And when OLAP comes to my mind, there's some latency, It's not real time as OLTP. And you say that what you do is cube and OLAP style thing, but real time?
Yes, absolutely. And that's the beauty of it. So it's an OLAP database at OLTP speeds. So it is actually real time. And so I have a demo where we stand up a Kafka instance that's reading from wiki events and getting all and if you've ever consumed wiki events, it's very chatty. Don't write it to your disk, you will run out of room. And it shows up instantly. Millisecond latency. I wouldn't use it for scientific stuff. It's not that accurate, but anything you want in a typical business scenario, it works. And that's one of the reasons we have such a very rich environment for people using it. Not to forget, it's open source, so you can implement it with zero cost and, well, the cost of running the platform. So, yeah. Anything else, guys? Yeah. So you have a configuration option of saying, hey, I want to create the StarTree table on this as the cardinality 1 and this as a 2. However, what it cubes is based on queries, right? So it's smart enough to know that, but the cardinality you can decide. And also, we log everything so we can do our own sort of look at what happened. Again, you can replay Kafka streams topics, so you can figure out what's going on and tweak the order if you got it wrong. And yes, there's a little bit of trial and error. It's not ChatGPT, but it's smart enough to know what to cube and what not to cube. So, thanks. So yeah, anything else? All right. Well, in that case.